page 57 and 58 in your book, we need to talk about the sum and difference of cubes. Sum and difference of cubes. And then if I have any time left, I need to get into solving quadratic equations. Do you need to know how to solve quadratic equations, or do you all remember how to solve quadratic equations? Maybe you already remember how to solve quadratic equations. This is in the hardcover book. Let's see what I can do with. I know I need to show you differences. My goodness, time gets away, doesn't it?
When will this video be ready?
I don't know. Number 4 on page 58. There's a problem that says x cubed minus 27. And there is a formula. There's a formula that says if you ever have x cubed minus y cubed, it could be written as x minus y times x squared plus xy plus y squared. That's a formula that's given to you. Now that wasn't discovered by somebody discovering how to factor. That was discovered by somebody taking this times this, and they played around with it, they multiplied it out, and they found that all the middle terms subtracted out. So we got this formula. Now there's another formula that says x cubed plus y cubed. It starts off with the same, x plus y. Same as this starts off with x minus y. X cubed minus y cubed starts off x minus y. X cubed plus y cubed starts off x plus y. And then the signs are slightly different. It would be x squared minus xy plus y squared. So those are two formulas that we need in order to factor a difference of cubes. Okay? Now, I'm going to bring number 4 down a ways. And I want to show you, I told you that there was a reason why when I did x squared minus y squared, I want to put the x minus y first. Do you see how that kind of builds you up to this pattern? X squared minus y squared. I think it should be x minus y times x plus y. Then you're set up to do x cubed minus y cubed is x minus y times this other thing. And x cubed plus y cubed, x plus y times this other factor. See? So that's why I think it's better to write x cubed, x squared minus y squared in that way. Now let me go back to number 4. Number 4 says x cubed minus 27. So, what minus what to start with? It starts off with a binomial. Do you see? Anytime you have a cube minus a cube, it's going to be a binomial times a trinomial. What's the binomial? X minus 3. X minus 3. And then, what's the trinomial going to end up with? There's going to be a trinomial out here. So, leave yourself some space. The way we build this trinomial is we take the first and square it. Okay? We take the first and square it. Then we have a sign that's the opposite of whatever was there. Change the sign, make it a plus. And then take the product. xy represents the product of these two terms. What's the product of those two without the signs involved? 3x. And then we take the last and square it, which would be 9. And the last is always positive. Last is always positive. Okay? Now, having done that, let's go to number 8. Number 8, the problem says x cubed plus 27. So what do you think we're going to do with x cubed plus 27? We're going to start off with what plus what? X plus 3. You see, if it's x cubed plus 27, we're going to start off with x plus 3. And then we're going to build a trinomial based upon the binomial. And the trinomial is going to be what? X squared, square the first, opposite sign, minus, the product of the two, which would be 3x, and the last squared, which would be plus 9, right? Plus 9. Any questions on that?
Okay. It says always going to be plus the last.
The last one's always going to be plus. Now, let me mention this. You ended up with a trinomial in every one of those. Do you know what? I have never seen a trinomial that you get down here that's going to factor again. I have never seen one. So usually you're used to factoring trinomials like crazy. Well, you don't have to even look at this. It's not going to factor again. I almost guarantee it. I have seen a special problem, but it's a very special problem. It's in college algebra, and it usually doesn't even occur in college algebra. So that will never factor again, really. Okay, let's take a more challenging problem, like, how about number 19? Number 19 on page 59 in the intermediate one step. 10x to the fifth y plus 80x squared y to the fourth. What is your first step in any factoring problem? Common factor. You can see a common factor there. 10x what? Squared
10x squared y.
and y. All right? So that'll be times what's left now? X cubed plus 8. We got the x squared out. Y cubed. Okay? Now, you see a cube plus a cube. All right? A cube plus a cube. So what we're going to do, we're going to have a binomial times a trinomial. Every time it's a binomial times a trinomial. And you bring down the 10x squared y. Now, what's going to be left? What's going to be the first?
X plus 2y.
X, okay, we got an x, and plus, and this would be 2y. X plus 2y. X plus 2y. Now, I want you to use the binomial to build the trinomial.
Negative 2xy.
All right, let's start with
X squared.
the first and squared. That's going to be what? X squared. Okay? Then what sign goes in there? Negative. There's got to be one negative sign in every formula. It's guaranteed to have a negative sign in it. So it's going to be negative. And then what? The product of the two. What's the product of the two?
Negative 2xy.
2xy. Okay? And then what sign always goes next?
Positive.
Positive. And whatever you do, there'll never be enough room in that trinomial. If you put the parentheses down there, it's almost a law of math. There will never be enough room to finish it. So always plan a big trinomial. All right? What's the last square going to be? 4y squared. 4y squared. Any question on that?
You took the,
Right.
you built
Do
the
it again.
trinomial. You built the trinomial off the binomial.
All right,
X squared.
I build the trinomial off the binomial. I take the binomial, I take the first and square it. I take the opposite sign. I take the product of the two, and then I do the last square. Okay? Yes?
How did you get that first binomial then?
The first binomial, all right, I take the cube root of this, which is x. And then I take the cube root of this, which is 2y. Did you notice I had special numbers there? 8, 27, 64, 125. It's going to be those special, all the way through this section. I should have mentioned that at the very beginning of this section. Look for those magic numbers, 8, 27, 64, 125. Those are the numbers it's going to be built on. Okay? Let me take a problem like number 24. Number 24. Number 24, it says 8x to the 6th plus 125y to the 6th. Now there's a big question here. What is going to be the binomial? So let's take this and figure out what would it be that you'd have to have cubed plus what cubed?
2x squared.
All right? Now, in order to get 8x to the 6th, we're going to have a 2, aren't we? And an x squared to the third would be x to the 6th, wouldn't it? Okay? And now what about this one? 125, is that a magic number for you? Does that ring a bell? 5, okay? That would have to be a 5, and then what?
Y squared.
Y squared, okay? Any question on that? Now, what we'll have to do is have a binomial. Do you know what the binomial is going to be? A binomial times a huge trinomial, okay? Now I got enough room, don't I? So what's the binomial going to be? First, 2x squared plus what? 5y squared. Okay? Now what's going to be the trinomial? The first part of the trinomial, we'll take the first and do what? Square it, right? Square the whole thing. What's it going to be when you square the whole thing? 2x squared squared. Now square the whole thing. Go ahead and square it out. What's it going to be? 4x to the 4th power. Don't be bashful. Go ahead and square the whole thing out. Now what sign goes next? Negative sign, opposite of whatever sign is there, always. Now what do we have to do?
Take the product.
The product, right? Remember the middle step here is the product. Product of those two. What's the product? Go ahead and do it.
10x squared.
10x squared y squared. And then what sign? Always? Plus? Plus what? 25y to the fourth. Okay? Now you got a nasty trinomial down here. Do we need to try to factor it some more?
Yes.
No.
No?
Never. Never. You'll never have to refactor this trinomial under normal circumstances. I say under normal circumstances because some college algebra teacher could pull something out of the woodwork and say, ha, this can be factored, but not like a trinomial. If it factors, it doesn't factor like an ordinary trinomial, does it? Okay? All right, now, there's one more section to mention briefly because I'm about out of time. In fact, I'm on borrowed time right now. And everybody get ready to sign a piece of paper before you leave here tonight because I'm going to owe you for your extra patience for me. I think that's worth a couple extra points.
On her test.
Maybe. Wherever you want to put it. Wherever you want to put it. Extra points don't get put on the test. Extra points get put in the book. I mean, it might be your lowest test grade and you drop it and count the final twice. And then you lost your points. So I keep the extra points somewhere in the book. Don't worry. Trust me, they'll be there for you. But now I need to talk about solving quadratic equations. And that will involve page 229 in the hardcover.